So Ali Ashford was working on an AWS lab over the weekend and noted that he had some struggles with getting the NAT policy to hit. And then he goes on to kind of explain some of the items that he configured both in AWS and on the firewall. And long story short, I definitely just need some suggestions to get this outbound NAT working. Well, Ali, you're definitely in luck today because we're going to dive super deep into this challenge that I'm sure others may be facing out there. And so, because of you, we've got today's video all set. Really, there's four different steps that we're going to go through today. And if I had to take a guess, if I was a betting man, it's probably step number four that is causing you to not get your configuration to working. But let's go ahead and take a high level look at an overview of what we've got today. And so if we go into our virtual firewall here in AWS, we see here that we've got our interfaces all set. ETH11 is going to be the public or outside interface. ETH12, the private or inside. We don't have any policy set up on either NAT or security, just the default permits on the intrazone traffic and the implicit deny on the interzone traffic. And because of that, there's no hits here in our traffic logs just yet. On the AWS side, we've got our Palo Alto firewall with three interfaces, management, public, and private. And then we've also got a test Linux box here separated in a server subnet. So it's a 3.100. Each of these third octet represents the subnet. And then, of course, the last octet is .100 for each of these interfaces. As you can see here, we've got our interfaces. And then for our route tables, again, to keep things simple, we basically have each of the subnet in their own dedicated route table. To get to that firewall to manage it, we needed to do the entry for the management. That's how we're able to, of course, console into the firewall. And that entry is just basically for all unknown traffic. It's pointing towards the internet gateway. So we know we're all good there as well. So let's go ahead and provide a graphic, if you don't mind. Let's see what we got here. So we'll draw this rectangle here. That's going to represent our VPC. And again, we said that CIDR was 10.0.0.0/16. And then we've got our Palo Alto firewall. And we'll say the .0.100 is our management interface. .1.100 is public. And on the firewall, that's ETH11. The dot there. Yes, I did. That looks crazy. Our .2.100 is private, as we can see here. And you take a guess, that's ETH12. And then bringing up the rear, but not to be forgotten, we've got our server subnet and the interface on this separate instance is .3.100. So that's a high level depiction of what we've got here. We're working in the outbound direction. So step number one is we need to do our route entries on the AWS side. Again, some of these can be done in any order, but today that's the order or the approach that we're taking. So for our Linux, this is again the packet that's basically making requests to 8.8.8. So for it to get off of its subnet, and then of course in the direction of this firewall, this server route table is going to need an entry for quad zeros or all unknown hosts. That's going to point to the ENI of this bad boy right here, this ETH12 of the firewall. Now, to then get the packet going from the inside interface to the outside, that's already known. We don't need a route table entry there. because you're going to see here that there's a, let's go, each of these route tables has this local route for the VPC. So they know how to reach resources inside of the VPC. And then if we go ahead and put internet here, and then we'll just make that crazy looking cloud. But we have our internet gateway, but we do need to get from here to here. And so for our public route table, it's going to look just like that management route table entry we have, and that's going to point to the internet gateway. And so with that said, let's go ahead and get it. Our server route table will hit edit routes, sign in again. Our apologies there, but as we were noted, we need to just click add route. And then for quad zeros, this again, to get to the Palo Alto firewall, we're going to need to find the network interface there. There's multiple ways to do that. And one of those ways is to simply go here to network interfaces. And for that private interface that we're going to be targeting, we see the ENI or the Elastic Network ID here. Click that button to copy it into our buffer. And then we'll select network interface, get rid of this and just paste, and we see it there. Subsequently, another way that we could have did this was to, as long as you've got good labeling and descriptions, you can start typing like private or PRIV, and then it will populate it there. We'll hit save changes. We'll then go back to route tables and we'll proceed with that second entry, which is our public subnet. We'll click routes, edit routes, add a route, quad zero, select internet gateway, and only one can be attached to a VPC. So that's the only option there. And boom, we're all good for step number one. Step number two, we need to do similarly the same. We've got the edges, the bounds, to get from this to this interface and this to the internet. But in the middle, the firewall itself, we're going to need some routes in there. So we're going to need two routes. We'll do a 1 and a 2 here. We'll call this firewall routes. And so for any unknown destination, we'll call this DR, default route. And we're going to, of course, make that destination quad zero. It needs to point to ETH11. And then in AWS, we know that on the subnets, especially for /24s, the .1 is going to be the gateway. So we need to send that to 10.0.1.1 to get that traffic out of the firewall onto AWS's backplane, .1 of that subnet, and then moving towards the internet gateway. Now for our outbound in that direction, those are all the routes we need. But for the response from the internet or from Google's DNS servers, we need to have a route that allows the firewall to know how to get back to this third octet .3, basically that Linux server. So we'll call this LAN, and we'll just make a supernet, basically the VPC cider. If we were to add 7 or 8 subnets later, we wouldn't need to come back and do this unless we want it to be more specific or more secure. But we'll just say to reach the destination of 10.0.0.0/16, use ETH12, which is that private or inside interface, and we're going to target 10.0.2.1. So let's go ahead and hop on back in here. We'll go to network. We'll go to virtual routers. We're using our default VR. And before we go there, our fib and our rib we see here, and it's basically the interface, the host route, the two inside and outside interface, and then the subnets for each of those. So let's go ahead and click default static routes. We'll expand this. We'll click add. And again, we called it DR quad zero. The interface we noted was ETH11. And that next hop was 10.0.1.1. All set there. Don't need to refine any metrics. And then for the response, we'll call this LAN. This will be 10.0.0/16. Interface will be eth12, and that next hop address is going to be 10.0.2.1, same to get it to the gateway of the private subnet. And that's our entries. We'll click OK. So step 2 out of 2, boom, we're cooking. Now, step 3 is to build or configure the policy, starting with our security rule. So we'll call this outbound NAT traffic. And then we'll leave the description blank, but in production, we would want to put one there. Source zone is going to be private. Destination will be public. Similarly, we would lock this down a little bit more for applications, but we're going to leave this quote unquote wide open for any services. The default action is allow, and so we're good there. So we've got one half done. Now that matching pair for the security and NAT policy is going to be here. We'll call this NAT, or we'll call it outbound NAT rule. We'll just say there. Source zone, private, destination zone, public. And then for our translation, generally 9 times out of 10, if you're going outbound, that there's a server on the inside, which in our case is going to be the inside interface of the firewall that needs to be translated, because when it goes out on the internet, RFC 1918 will drop that. So it's our source address. Which address is changing? It's going to change to the public IP that's associated with the outside interface of the firewall. So we will click dynamic IP and port. We'll click interface address, and the interface is eth11 is what we want this to be translated to. And AWS will magically behind the scenes take care of the rest. If this was inbound coming in and targeting like a server, then that's the destination that generally we would use there. So that's step 3 out of 3. But before we commit this change, let's go back to instances. And then for our Linux demo, in a prior video, we talked about how to connect to this. If we hit connect here with a VPC endpoint, we can use this EC2 instance connect. And then we just simply need to hit connect, and we don't need a VPN or anything like that. So we're going to basically start our pings towards quad 8, just like you did there, Ali. And this should not be working yet. And even when this commit goes through, because like I noted, you're going to need all 4 steps. So we'll commit with no description, and then we'll be all set. But definitely wanted to thank you. Really, 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 like I said, it's early morning here, but I love those comments that not only challenge the brain, but we know that it's going to help the community out there. Um, any problem that we have, we're typically not the only one that will see it in the tech world. So I'm hoping you guys and gals definitely get some value out of that. This should push pretty quickly. It's not a panorama that's needs to get the rule and then push it to the firewall. So we're all set there. We can refresh here on some hits. You can see nothing yet on the NAT. Here we'll click adjust columns. No response there. Nothing just yet. And likewise on our instance connection there. Therein lies the quandary of rule number 4, step number 4. So if we go back to our network interfaces, then we need to talk about a default stance that AWS has, and that's this. In AWS, there's a configuration called source destination check that by default on all interfaces, it's set to true or enabled. And what this refers to is that it's a feature that ensures an EC2 instance only receives traffic that's either explicitly sent from its own IP address or intended for its IP address. This essentially prevents it from receiving unintended traffic by verifying that the source and destination of the packet match the instance's network interface details. So with the firewall, we know that it's not that it's a pass through, but this server in this specific example, it's going to come in on that private interface, but it's not destined there. It needs to be moved to the outside interface to get to the internet. Same thing with the response, but the reverse. So typically with this enable, that packet and all those packets are going to be dropped because that traffic's not destined for the private interface. So we need to, with this interface, click Actions, change source destination, and uncheck this box. And this will fix the outbound NAT. If we did global protect, or if we were NATing inbound towards a server or servers, we would need to do that on the public interface, but as well. So as soon as we hit save there, we'll see our pings start coming through successfully, and we're cooking. We're in business. So if we go back here and refresh, we'll see this hit count. We're already at 3. We'll go to basically monitor traffic, and we can see these pings starting to come in. So if we come to columns, let's go ahead and get rid of, we don't need to see source user, source dynamic address group, destination. Oh, yeah, this either. But let's scroll down a wee bit and let's see if NAT was applied. We'll do our NAT source IP, destination IP, and you can highlight or change any of these to suit your bill. But we can see that the destination we know is quad 8. We see that NAT is being applied, that the source IP is, as we noted, that inside interface that's going to be translated. It's not the server IP. And then, of course, the same NAT destination, that's not being changed or camouflaged from a layer 3 perspective. We need to see that full packet. Of course, we would click here and get the details, but we're all good. We're in business. The only other thing for you that may be an issue, and it's not that it's a got you, but when you're attaching network interfaces afterwards and say you did it wrong and you disconnected, there is a chance that you're believing or assuming that the ETH11 is like, if you did it in my order, it's the public. But there's two places to check that. Underneath, if we highlight our firewall, and then we see this device index. So counting canonically, this index of 0 is the first interface from the AWS perspective. On the Palo, we don't see this. We'd have to get into CLI to manipulate or see logs of the management traffic. But that ETH11 that we're calling it is going to be this index 1. And so this is safely public, but there's a chance that we assume that, but actually AWS attached this private and that index value. So you need to do that as well. And the second place is underneath networking, manage IP address. You get similar details here. And this is also where if you needed to do like add 5 or 4, it's a limitation on different family sizes for each firewall. I think the limit is 4 interfaces for X large, but 4 or 8. But this way, on that single outside interface, you could add new IP addresses. You can make this 0.101, and then you could give that a new elastic IP 102 elastic. And that way you can do one-to-one NATs on that single IP on a virtual appliance in AWS. But again, I definitely want to thank you so much for commenting there. Those are the comments that I love to see. I love every comment, don't get me wrong, but the ones that will pique our curiosity. And like I said, I think this was better answered in a video Vice giving you a long explanation to comment. And maybe it was or wasn't that, but hopefully it is this step number 4. And again, for each and every one of you out there, thank you so much. The year's almost wrapping up. It's almost upon us. So I just want to thank you for rocking it here with me today. Holiday season, so wishing you and yours all the best. And until next time, stay safe, take care of yourself. Peace.